Yeah. That's just.
I hate people. I know exactly what you mean.
Good morning, everyone. We are moving to next step of applying what we learned in the finite element using a finite element application software, namely ANSYS. And I would like to mention that ANSYS is not only used to solve structure or machine design problem, but ANSYS is a multi-physics platform that allow you to do structure, mechanical, CFD, fluids, electromagnetic, and more. We are going to be focused on this in this class on using ANSYS for mechanical structure as it applies to our machine design class. And my goal for today is to demonstrate how the software package is going to be used from beginning to end. And this might be too much for one class. I would try as much as possible to show you all the steps and ask you to please work with me through them, because that's one of the best ways to learn. And this is one of the main reasons we are in a computer lab, so you can launch ANSYS with me and work as we go. I would ask you to please try not to skip a step. If you miss something, please let me know, so I make sure everyone is going up to speed with me. And I'm going to start from scratch, and I'm going to demonstrate solving a simple cantilever beam problem, where we are going to be looking at this cantilever beam that is going to be made out of some aluminum alloy that has a modulus of elasticity E of 10 million psi and a Poisson's ratio of 0.3. This beam is 120 inches long, and it is going to be subject to a 10 kip load at the free end. It is fixed at the left end. It has a rectangular cross section, and the cross section is 6 inches by 12 inches. And of course, it is going to be loaded about its strong axis. So this is the reason I'm showing my rectangular section oriented vertically. So when you go to your computer, and I go to my start, and look at the applications, I'm going to find ANSYS 2020 R2. And as I mentioned at the beginning of the semester, this is the release that Embry-Riddle is currently using in all the computer labs that comes on the image with the image. I ask you to please, if you're going to download a copy to use on your personal computer, to make sure that you are also using 2020 R2, because the files are not backward compatible. And I want to make sure if you create a file at home, you're still able to run it on a university machine, or if you're submitting it for grading, I'm still able to open your file. So we're all going to try to stick to the 2020 edition, right? And I also mentioned at the beginning of the semester that you may be interested in getting a copy of the finite element simulations with ANSYS Workbench 2020. It's also 2021 is available. There aren't really many changes. This is a nice reference if you would like to learn more about ANSYS. So when I go to ANSYS 2020 R2, you're going to find that there are all these different options to start. Now we are going to be using ANSYS Workbench. ANSYS Workbench. We're going to go all the way till the very last option where it says Workbench 2020 R2. And I'm going to click this. And this would launch ANSYS Workbench for me. And I would like also to let you know that we are going to be using 3 different tools through ANSYS Workbench. So Workbench is going to be the first, but we are also using Design Modeler as well as Mechanical. So the 3 tools we are using would be Workbench. From Workbench, we are going to launch Design Modeler. And from Workbench also, we are going to be launching ANSYS Mechanical. Okay. So here comes our Workbench, ANSYS Workbench, and we are looking here at the graphical user interface. We have our menus at the top. We have our toolbars. We have a toolbox that have the analysis systems, the component systems, custom systems, design exploration, and ACT. We have our project schematic here, where we're going to see our projects. And Workbench is a kind of a project/data management tool where multiple teams may be sharing the same project, and each one could be contributing to a component. And I can create components, like for example, I can come here to components and create a geometry. I double click on it, and here comes my geometry. So maybe I'm the engineer responsible for creating the CAD. Once the CAD is created, someone else is going to pick the CAD to do the mechanical simulation. And the one that we're going to be using here is static structure. So I'm going to use the geometry created for my static structure. Maybe I have another engineer, let's say, working on or using Fluent, and they are going to be using the same geometry to run the Fluent analysis or run a thermal analysis. And maybe even the results of that thermal analysis is going to be used for a static structural analysis. So this is basically the purpose of Workbench, and there are a few other things that we can do in Workbench. And my focus is going to be on this top static structure analysis. So this is here is just to show you a demo about how Workbench may be used to manage a project and share data. Like I'm sharing the geometry, I'm sharing results, and it's a great tool in that regards. So I have not saved the project, but I'm going to start a new clean one. So I'm not going to save this, but I'm going to start. Do you want to save it? I'm going to say no. I'm going to start a fresh project. And in that project, we are going to focus on static structure analysis. So in order to create one, I'm simply going to double click on it. When I'm looking at a static structure analysis, you see we have under static structure, we have 6 cells. So the numbers are 1 through 7 because it's counting the top cell where it says static structure. But basically, each of this cell represent a step that we're going to go through in order to complete a static structure analysis. And as you expect from what we learned about the finite element method, we are going to need a geometry that we discretize and break into elements. For each of these elements, we write element stiffness matrices. These matrices depend on the material properties or the stiffness. So having said that, we're going to need engineering data or material properties. This part also is going to be constrained, have boundary condition. So for example, for my beam, it is constrained at the left end. My part is going to be loaded. There must be an action to cause a behavior. So in this case, my beam is loaded with the stem kip at the right free end. So I repeat, we're going to need material properties. We're going to need a geometry. We're going to need a mesh. We're going to need boundary conditions. We're going to need loads. These are all inputs. Once I have my main inputs, I can assemble the global stiffness equation and see if there is a solution. So I go to a solution. Once I have a solution, we can start doing the post-processing and looking for results. These results could be reactions, could be deformations, could be internal forces, exactly like what we did by hand in class and what you did for homework number 4. But we're using the ANSYS application to do the math for us. We provide an input, and there is lots of work that is done here behind the scenes, not only for the simple problem that we are doing in class, but for even more complex problems. So if we go through a structural system, it's going to take us through the steps from engineering data, where we define the material, then we define the geometry, then we define the mesh, the boundary condition, and the loads in the model. So this is the model, the mesh, and the setup. And then we find the solution, and then we define our results. These are going to be the steps. Engineering data is managed within Workbench. It's a database. So if I come here to engineering data, and if I want to work on any of these steps, I usually double click or right click to choose something specific. So if I double click on engineering data, within Workbench, it takes me from the project tab to an engineering data tab. And under engineering data, you would notice that I have a material here called structure steel. I can go to engineering data sources and look for other types of material. So you can have some engineering data sources that you use to import or add a material, or I can add a material manually. So if you look here under structure steel, so this is like the default material that comes with it, the way it's installed. And I can add my favorite material. So it says click here to add a new material. So I'm going to click here, and I'm going to create a material that we're going to use for our example, and I'm going to call it class material. Enter. So I added a material. But if you look carefully, there is a question mark next to the material. What does that mean? I mean, my material is not yet properly defined. When we learned about the finite element method, I mentioned that everything we do in this class is going to be linear elastic behavior. And if I'm using metals for my part, usually they're going to have an isotropic behavior. So in order for me to define the material properties, I'm going to have to check from my toolbox, what kind of properties do I need to input? And you see here, there is like physical properties, linear elastic, hyperelastic, and so on. Plasticity, creep, life strength. The one that I need to input are specifically going to be Young's modulus of elasticity and Poisson's ratio. And these are going to be under linear elastic. I'm going to pick isotropic elasticity. And I'm going to double click isotropic elasticity. And this will launch the properties of outline. And it says here, row 4 class material. And if we look at under isotropic elasticity, there is Young's modulus and Poisson's ratio. These are the ones we're going to define, and they are highlighted in yellow. When I look carefully at this, you see under units, it's saying Pascal. That's not the units we want to work in. So I'm not using SI units, but I want to use US engineering units. So before I go any further, I want to make sure my units are set correctly. So I will go to units, and I will choose US engineering, where it shows pound, inch, seconds, and so on. So I'm going to pick this US engineering. And I also are going to go to units. I want to make sure to display values in project units. So now it's saying here PSI. That's what I want to do. So for Young's modulus, I'm going to put 10 million. So I'm going to put 10 e to the 6, enter. For Poisson's ratio, I'm going to simply put a 0.3. And most of the time, if you're using metals, you can use a 0.3 for Poisson's ratio, enter. Now there is no longer a question mark next to the class material because we did input Poisson's ratio and the modulus of elasticity. And these two are sufficient for a linear elastic structure analysis. If you have any questions, I'll be happy to take it. But let's make sure we all follow along. I can toggle back between project and engineering data as needed. So I'm going to go back to my project, and I have confidence now that I added the material we're going to use for our part. Next, we're going to go to the geometry. And I don't want you to double click on geometry, because if you double click, it will use the default CAD package, which is Space Claim. Until 2017, Design Modeler was the default CAD package. Then they changed it to Space Claim. Now, you can also use your own CAD package, like CATIA, like Creo, like SolidWorks. You can import a step file. For our class purposes, we're going to keep it to simple geometry because we want to focus on learning the finite element method and the process. So Design Modeler is perfectly suited for that, for simple geometry. So I want to keep using Design Modeler. So if I right click on geometry, you see highlighted the top, which is the default, is a Space Claim geometry. Then there is the Design Modeler geometry, and beneath that you can import geometry. And this is where you would import a CAD package, a CAD file. And again, there are all these different types of files. So pretty much you can create your geometry in any CAD package. Again, in this class, we're not going to need that. We're going to be using Design Modeler to create simple geometry. Design Modeler also can be used to edit some of the geometry features as needed. So I'm going to exit from here, cancel, and I'm going to go right click on geometry, and I'm going to choose New Design Modeler Geometry. And if you look at the left bottom, it says Starting Design Modeler. So this is launching our second tool that we are going to be using. So we started with Workbench for project and data management. Now we are going to Design Modeler to create our geometry. The good news, our geometry is very simple. We basically have a straight line to represent a beam. Keeping in mind that I want ANSYS to realize that this is going to become a beam, I'm going to use a special feature called a line concept. And this line is treated as a body that makes a part. And I can simply create it by defining 2 points, a start point and an end point. If my beam is 120 inches long, I can consider my start points at the origin and my end points along the x-axis. This is x and this is y, would be at 120 inches, 0 and 0. So I'll be working in the x-y plane. And if you look at Design Modeler, and everyone is familiar with CAD packages. So you see here our default planes and also, the coordinate system. And I can also show the default planes. I can also show my default planes, the X, Y, ZX, and YZ. And since we're going to be working on the XY, I'm going to select the Z axis to show my XY plane. If I look carefully at the ruler at the bottom, this is showing units in meters. And then we are working in inches. So I'm going to go to my units before I do anything and make sure to change it to inches. Now we are going to be working in the first quadrant. So we're going to zoom here. This is 4 inch. Definitely, that's not the scale we want. So I can use my wheel to change the scale. And if I look at the tree outline, I have my 3 default planes, and I do not have any parts or bodies yet. Within Design Modeler, we're going to be primarily using the modeling and sketching. Today, we're not going to be really doing any sketching. We are just going to be creating points and a line concept and sections. So I'm going to start by creating my 2 points. I go create, point, and here it says point 1. And you'll see next to point 1, there is this yellow flash icon, meaning that this is still work in progress. We still need to define it. If I look under the modeling here, you see that there is details view, details of point 1, and I can define the name of the point. It's a construction point. And it says here definition from coordinate files. No, I'm gonna simply use manual input to input my coordinates. And I'm gonna start at the origin. So yes, 0, 0, and 0. If I like that, I need to generate my point. I can use F5 or click generate. And this creates my first point, point 1. I'm going to repeat this process to create point 2. So I'm going to go create a point. And this becomes point 2. I'm going to change the definition method to manual input. And my X ordinate now is 120 inches. The Y is 0. The Z is 0. I can click F5 to generate my point. I will zoom out so I can see my 2 points. Here are my 2 points in the XY plane. Next, we are going to create a line concept. So I go from to concept, and there it says here lines from points. So I can go to lines from point. I'm seeing here the line that I'm working on. And when I look at the detail view of the line, it's line 1, it is prompting me to select my points. So it says point segments. So I'm going to use my mouse and a left click on the first point. Then I use my control button and my left mouse click to select the second point. It is showing me the line segment that I'm about to create. I want to verify that this is what I intend to do. So it's showing it in green. If I like it, I can go apply. It changed it from green to this light blue color. It is still not yet generated. In order for me to generate it, I can click F5 or simply click generate. And here comes my line in gray, light gray. Please note that as soon as this line is created, it is considered a body that makes my part. So now I have one part and one body. If I expand on the tree outline, I see my line body that makes my part. When I select this line body, you'll notice under the detail view, it is highlighting a cross section and it says it is not selected because we really haven't defined any cross sections yet. Because this is a line concept, even as a geometry is treated as a line, but there must be a section associated with it. So I need to define my section. So I go to concept again, and at the very bottom, it says cross section. And I get few options. Can create a rectangular, a circular, circular tube, I section, Z section, L section. You can even define your own section. So here we are going to go with a rectangular section. And it looks like we are in sketching mode, but we're really not going to sketch anything. We are just going to define the width and the height of the rectangular section. So the width here is 6-inch B, and the height is 12 inches. I'm going to zoom out so I can see my rectangular section. And please note this rectangular section is showing a y-axis in green. This y-axis of the section is different than the y-axis of my line. But keep that in mind. So I have here my section defined as rectangular 1. I'm going to go to line body and choose rectangular 1 as my section. Now I can verify that this section got attached to my line. By doing something like rendering, it is still a line. It's not a 3D geometry. But if I go to view and I select cross-section solids, look at this. It is showing my section attached to my line. But my line is showing in yellow. And there is a check mark in yellow. The reason that is the case, because I have not checked, verified, or edited how the section is aligned. By default, Design Modeler is going to take this Y direction and oriented with the Z direction here. And this is how we ended up with the section oriented along its weak axis, not the strong axis. We have an opportunity to edit this, but only one opportunity. So please pay attention and follow with me. So in order for me to fix that, you see here the green arrow is oriented along the Z. Really what we want to do is either to rotate this 90 degrees or to make sure that this green yellow axis is oriented not with the Z, but with the Y axis. And I can go either route. Where I'm going to do that, I'm going to right click on the line body. And I get the first option. And again, you only get it once. Once you edit it, you cannot go back and change it. I'm going to do select unaligned line edges. And it opens here a detailed view.
Back to where you made the dimensions on that rectangle.
Okay, on the cross section here.
Yes.
Okay, I did the B, I set it to 6, and H, I set it to 12. Is that your question?
Like the steps after that.
After defining my rectangular section, the only thing I did is I went to the line body and I made sure that cross section, I have rectangular one selected. So when you come here, originally, I didn't have any sections. Now I have none and rectangular one. So I picked rectangular one. Good. Now I still have this yellow check mark next to the line body. So I go to the line body and I do a right click and I go select unaligned line edges. When I do this, I get this menu. And I want to be careful before I make changes and accept it because I cannot change it. I'm going to have to start all over. Okay. So everyone is following? It is very important to make sure we are all following along. So again, if you have any questions, please feel free to stop me. So I go back to my line body. And one thing I can do is I can come here and give it a 90-degree rotation. And look at this. If I go 90-degree, enter, this fixes it.
How do we get the 3D view?
Okay, if you go to view,
That.
okay, and please keep in mind, it is not 3D geometry. It's just like rendering. I'm just showing a section attached to it. All right. So if this 90-degree did it, but we know when it went positive 90-degree, my positive Y axis is oriented with along the negative Y direction. So I'm going to bring this back to 0. And I'm going to show you another way. I can come here. You see cross-section alignment. It says none. I haven't done anything. And it's showing here with the plus Z by default. And instead of that, I can come here and choose, and instead of the plus Z, I can choose the plus Y. So I can come here and select this. And this is plus Y. And yes, I can go from plus to minus, but I'm okay with the plus. So I can choose the plus Y and say apply. And look at this. It changed my plus Y or my Y axis direction of the section to be oriented with the plus Y of my geometry. So now I have my section oriented correctly. We are now done with the geometry. Before we move any further, let me save the project. And I can save the project here or save it from Workbench. So I can come here and go like File, Save the project. And it does not have a name yet, and I want to choose a folder. So I'm going to use 2024, and I'm going to say first class demo. And please note when I save, it says save as type, and it's showing here project file, and it gives it the extension WBPJ for Workbench project. And I want to say here that this WBPJ really has links to another directory or folder with many files. So it is useless to share that WBPJ. Even if you're working within your computer and take it to another directory, you really cannot do much with it because it will get lost. So anytime we need to share, and this is important when you're submitting homeworks or quizzes or exams, you want to go within Workbench and go to File and create an archive. So now it can save an archive file as a Workbench zipped project or PZ. I can save it here. And I can save it with results or without results, an important file external to the project directly. I make one simple file that I can submit. So I go archive. And this will create another file. So if I go to my folder, I have here first class demo, a WB, and I also have a WBPZ. And I also have this directory that says first class demo files, and it shows like other subdirectories and files. That's why it is important when you share that you make sure you are using the WBPZ file. Good? Question?
How do you make the archive again?
File, archive. From Workbench, not from Design Modeler. Got it? Okay. So now I can toggle between Workbench and Design Modeler, or even launch another tool like Mechanical. So you look here at the steps of a structure analysis system. We are done with the engineering data, and there is also a green check mark next to the geometry. Next step is to work on my mesh, my loads, my constraints, my solution, my results. So this is all going to take place within Mechanical. And I'm going to launch this simply by double-clicking the model. It says here, starting Mechanical. Here comes Mechanical with its interface. And please note that it did bring over my geometry. So again, the Mechanical interface comes with the menus, the toolboxes, the tree outline, the graphics area. Oops, I'm sorry. Oops. Here comes the Mechanical, right? It brings my geometry as a straight line. And I see here my menus, my toolboxes, and these toolboxes are going to change depending on which menu you are selecting. And as we go through, there is a tree outline, there is a graphics area here, and under the outline, there are also details. And these details are going to change depending on which step we're in or which item we are selecting of the tree outline. So you can see here, this is my line. I do not see my points, but this is something I can turn on and off. So if I go to display, I can turn on my vertices, show vertices, so that I can see my 2 points. So I simply have my 2 points and my line. And I'm going to select the Z-axis to show my line in the XY plane. So when I look at the geometry, I can expand that and I see my line body. And I want to show you here that if I go to the line body, which is selected now, If you look at the details of the line body, if I go down, I see material and look at the assignment. It is getting the default material, but that's not what we want. So I want to be able to go select structure steel and the arrow next to it and choose the material. It is showing my 3 favorite material that I've set. And it's also showing the one that we created. So I'm going to select the class material. If you can please minimize the side talks because they're distracting to me. It's very hard to focus. So I select class material, and now class material has been assigned to the line body. If you expand material, you see the materials that we are using here or we can use within the project. There is also the cross-section that we've defined. So we have our geometry with the proper material assigned to it. The next step would be to discretize, to create a mesh. You see here a mesh, and there is a yellow icon, flash icon. If I right click on it, I can go generate a mesh, and it created a mesh. I have to say that every time we create a mesh, we have to make a conscious decision about what type of elements are we going to be using for that mesh. And in some cases, we use a hybrid mesh, more than one type of element. Here we are looking at a simple problem where we're going to be using beam elements. And as I mentioned beam element, I have to tell you that the beam element in ANSYS can be used to model a beam, a shaft, or even a bar in 3D. So it's a very capable element, unlike the simple spring element that we use when we did the hand calculation. So now I have all these elements to model this simple cantilever beam problem. Next, I need to define my supports and my loads. Supports and loads. So I'm going to go to static structure. And please note, as I move from one step to the other, if I'm looking at the environment here, not the display, the environment will change. Like look at the environment for the mesh. I go to static structure. I get here loads and supports. So we need to define supports. If I click supports, there are different types of supports. We're keeping it very simple today. We're just using a fixed support. And I really just want to look at the beam simple geometry. I can go to display and turn off thick shell beam and show mesh. So I'm looking at simple geometry. What I did is I went to display and I turned off the thick shell and cross section and show mesh. So if I put the cross section, here it goes. I don't want that. I want to see simple geometry. So I turn this off. So I'm just looking at the line and 2 points. And I'm going to go back to static structure. And I'm going to go back to environment. So I can see the environment toolbar. From that environment toolbar, I'm going to select a fixed support. And when you are selecting, you have the option to use the smart select, where you can pick a vertex, an edge, or a face, or you can specify a vertex select, an edge, or a face. So if you can manage with the smart select, which I can come here, I can select an edge or select a vertex. If I can do it, I'm going to do that. And I'm applying my fixed support to the left point. I go apply. And here comes my fixed support at my left end. Next, I am going to apply my load or force. There are different types of loads. that we can define, we are simply going to use a point force. So I'm not going to use any of these. I'm just going to go select a force. When I am defining a force, you see there is a question mark. And it's really nice and important to look at my tree outline, because I have created two fixed supports, one that I failed to continue to define, and the other one I defined it correctly. So I'm going to delete this extra one. So I'm going to come here and delete. And by the way, I can always rename my support. I can come here and change. For example, I can get rid of this too. So now I called it fixed support. My force is still in definition. And if I look at the details of the force, it's expecting where the force is applied. So I'm going to come here and select my right vertex and go apply. I still did not define the force vector. What's the magnitude and the direction? And I can define it by a vector, or I can come here to define by and choose components. When I choose components, in this case, I only have a component in the Y direction. So I'm going to go to the Y component. And before I do anything, I notice that my units are still in Newton. So I want to make sure I keep my units consistent. So I'm going to go home, units, and I'm going to change this to US custom. Now I'm showing it in pound force. I'm going to go to the Y component and make sure to apply a negative 10,000 pound force because I have 10 kips. And here's the icon showing my force. Still static structure is work in progress because I never ran a solution. I never put together the element stiffness matrices, the global stiffness matrix, and checked for a solution. I want to check before I run for a solution. I have my support and I have my force applied at the free end. Now I'm ready to solve. So I'm going to click the solve button or click F1, F5. And now it's working on a solution. If I go to see, it's building the mathematical model. It is solving the mathematical model. If I go to Workbench, I get the model check mark. Once I have a solution, I have these green check marks. So you see it's updating my static structure analysis in Workbench as it run the numbers. I do have a solution, but I don't see any results to look at. I need to define my results. So I'm going to go to my solution. And the first thing I like to check is to see how my part is behaving. Is it really doing what I expect it to do? So in order for me to find this, I'm going to go to my solution environment, and I'm going to look at results, and I'm going to pick the very first one, deformation, and I'm going to pick the total deformation. This defines a result for me to look at, and I still have the flash icon, so I did not do any numbers. I'm going to go like solve, and look at this. It is showing me how my part is going to deform. I can even play an animation. Is this really doing like a cantilever beam? Isn't that what we expected? Yes. Zero deflection, zero rotation at the left end, maximum deflection at the free end. Isn't that cool? So we can see it, we like it, and it is doing what we expect. So we are happy. We want to look at more numbers. So I can come here. Of course, I can read if I stop this. You can see here the numbers and the color. We call this a fringe plot. So I can look at it and say, oh, the maximum is right here. I can even show where the maximum is. So it points that the maximum is here. And the maximum is this 0.67 inch. Of course, minimum is 0, and it's showing it here. I can go to solution again and go to a probe and specify a deformation at the free end and say apply. And let's say we want to be specific and result selection. We want to look at the y-axis deformation. Remember when you calculated deflection in the y and the z and find the resultants? Of course, here there is nothing happening in the z. So I expect the y to be the same as the total. But at least it's going to show me whether it's negative or positive. So now if I created this probe, and if I go like solve, I can go to the deformation probe and read the number. And it's telling me here that the value in the y-axis is minus 0.671.
So we can use this deformation code to find where the deformation is in the center of the beam as well.
If you have a vertex to select, but if you do not, you won't be able to select.
So you'd have to draw like two lines kind of with points.
Yeah, you got it. Good question. I can also use a probe to find the reactions. You know, we solve for deformation. We also solve for reactions. So I can go like probe, and I can go force reaction and select the fixed support. This is where we want to find the force reaction. I can even do a moment reaction, probe, moment reaction, and I select my fixed support. Now you get to choose the support because I may have multiple supports. In this case, we only have one, so it makes it easy. So now I have a probe for the force and for the moment reaction. Of course, you saw me how it was the deformation. I defined the deformation in a specific direction. Now I can solve for this war reaction. So I go solve and force reaction. As we expect, we are applying 10 kip, we get a 10 kip reaction. How about the moment? The moment here should be 10 multiplied by 10,000 times 120, right? So if I look at the moment reaction, we are getting the 1.2 million pound force inch as we expect. Not only that, but since this is a beam, I have a beam tool that allow me to see the internal forces. So if I go back to the solution, you see here beam results and tools. If I go to beam results diagram, I can show the axial force. I can show the bending moment. I can show the torsional moment. I can show the shear force. So I'm adding all of these results and I click solve. And here are the results. Axial force. We don't have any axial force, so it's all 0. Bending moment. I'm getting the maximum bending moment at the fixed support and 0 at the free end. Torsional moment. We don't have any torsion. Shear should be constant, and we have this 10,000 throughout the beam, right? Not only that, we can draw shear and moment diagrams. But in order to draw shear and moment diagram, we need to define what ANSYS call a path. You remember when we drew shear and moment diagram, we always start from the left and go all the way to the right. So I need to define the path or my edge. In order to do that, I'm going to have to go to my model, right click and say insert. And I'm going to use construction geometry and specifically a path. It created here an undefined path on the project's outline. I'm gonna go to this path and I'm looking at the definition, and I want to make sure that this path is not defined from 2 points, but it's rather defined using an edge. And I'm gonna come here and select an edge, which we only have one. I'm gonna say apply, showing here my start point and my end point. So we're gonna start from the left and go to the right. Now I'm gonna go back to my solution and to my beam results diagram, and I'm gonna do shear and moment diagram. It's asking me for a path. I already defined one, so I'm gonna select path. I just called it path. Once I have this, I'm ready to click solve. And now I can look at my shear, my moment, as well as my deflection. The shear is 10,000 throughout. The moment is maximum at the fixed end and 0 at the free end. Displacement is 0 at the fixed end, and I get a maximum of 0.671 at the free end. If I want to play with these outside, I can come here, look at the tabular data, right click, and I can export it. I can take it to an Excel sheet and do anything I want to do with it. So how do you like that?
Calculating stuff out. There it is.
But now, because you've done it, you can make sense out of it, right? I could not have started you with ANSYS before you've drawn shear and moment diagrams in statics, right? Looked at stresses in solids, and looked at how to design parts in machine design. Now we are ready to use it, and hopefully with the little background we have in finite element methods, we can make sense out of this. Once I'm done, I want to save my project, and I can do it either from Design Modeler or from Mechanical or from Workbench. I come here, it is still saving. Now it is saved, I can archive it. So if I look here at my directory, on my first class demo, you see here the timestamp for the file itself, 1048. But for the zip file, I never updated that. So I want to go back and update the archive. So I go File, Archive, and it's going to ask me if I want to overwrite it. Do you want to replace it? Yes. And here it's going to save one with the results and the solution, Archive. Now, if I go back, my first class demo WBPZ is saved at 1049. And I have something that I can share that has everything that we have done today. So again, the purpose of this class today is to take you through a quick run through what we're going to be doing in ANSYS Workbench, show you the capability, and we did it to a very simple problem. I know there was quite a bit to learn, and you want to play with it a little bit. And I'm going to do another example on Tuesday. I'm going to work the class example that we did by hand. Then you should be also capable of completing homework number 5, where we're going to start using ANSYS Workbench to solve the same problem you did by hand using ANSYS Workbench. Any questions?
What is the quiz we have on Tuesday?
I think we're going to have to move that. We're not ready for a quiz yet. Oh, no, we can do a quiz.
Because it's quiz to the finite element procedures.
Correct. This would be on the finite element method that we've done, and you applied it to homework 4. We can move it to Thursday to give you more time to prepare for it, if you prefer, right? And continue working on ANSYS. Thank you for bringing this up. Good. Any more questions? The quiz is going to be in class. Right. Good. And the quiz is going to be closed notes, closed book. Closed notes, closed book. And it's going to be specific to the two classes we did on ANSYS. I'm sorry, on finite element methods. I'm sorry. I'm thinking ANSYS today. Okay, so it's going to be very specific to homework 4 and the two classes we did on the finite element methods. I hope you're all excited about ANSYS and getting it to use to solve some of the problems that we've already done by hand. I think it's very interesting, and I hope you all enjoy using it. Any questions? Okay, if not, enjoy the weekend, and we'll see you all on Tuesday. Thank you.